The advent of 4K is really the first step for what I'll call television experience online. In the past it's always been very low bit rates, very small picture sizes, and it's really been about snacking video. I wouldn't say that television as we know it has been sort of synonymous with what we've been calling video streaming on the internet. So 4K is really the first, I would say, high quality, large screen lean back experience, which is that television today isn't consumed in 6:9 letterbox formats. It's really consumed on 65-inch and 90-inch televisions. And so we all know that 1 megabit streams aren't going to power large screen TVs. It has to be higher bit rates. And so 4K is really that first push of the quality bar. Now, that said, let me back up for a second, because you mentioned the HBO outages and you mentioned the Oscar outages. Those are actually not due to increased bandwidth. That's not due to 4K, and it's also not due to last mile. Those outages occurred back upstream, actually within workflow, so in ingest points or authentication gateways. Those are where the volume of viewers actually causes their issues. So there's really two different problems that are brewing today. One is you need to get to a large lean back experience, which is what television expects, and you got to go to a large screen that requires very high bit rates, while simultaneously you have this mad dash of viewers online. Now you combine those things and you can imagine there's going to be massive congestion and failure, because the Oscars event, I would guess, was probably streamed anywhere from 400K up to maybe 3 meg. The HBO, I know where those bit rates are encoded, and those are anywhere from 500K up to, I think, 7 meg is their top bit rate. Far from massive 64-inch television bit rates, and their distributions are even down at the low end. So again, volume hit that, but again, as they start to increase bit rates, they're actually chasing two problems: the volume of viewers that are going to come watch, and the fact that that volume is going to be consuming bit rates that are exponentially higher than what are available today. And that's what poses the problem for television on the internet. It's not really just about 4K, it's about really managing both. Managing the volatility of consumption, meaning the number of viewers, and then also the fact that you have to start pushing simultaneously higher bit rates. And that's where, if you look at television as it exists today on what I say modern television, but it's probably, we can start calling it archaic television, where it's a very controlled distribution strategy, where you actually publish to operators, and then they publish over head-end networks single streams simultaneously to all their homes. The internet doesn't offer that. So the internet offers variability. It's not a controlled network. You're actually using a shared internet. You're using a shared last mile. You're using shared CDNs. And then on top of that, the fact that the consumption patterns are no longer simultaneous, meaning today when you want to watch American Idol or you want to watch Entertainment Tonight, you know exactly what time that's on, and you know what channel that's on. And whether you watch it at that time slot on the channel or you DVR it, the publishing is happening at the same time. Internet video is, I want to watch it when I want to watch, where I want to watch, and I'm going to decide what I want to watch at any given day. So I could go watch ET a month on an old episode, or I could watch today's episode. It's my call. I'm going to watch it where I want to watch it. So no longer can you just publish to a single access point. I'm going to grab my iPad and I'm going to watch it at my airport. And then I'm going to land in Denver and I'm going to finish it. So I'm going to consume it when, where, and how I want. And that's what the internet offers. And so it's that variability that I think offer publishers major problems, because you can't predict who's going to watch. You can't predict how many are going to watch. And all simultaneously, you have to somehow maximize the experience for both small screen as well as 64-inch televisions. So that variability is what Conviva is solving, and we solve it through control. Obviously that's a logical connection. When you have variability, the solution to variability is to somehow get control, and that's Conviva's intelligent real-time control platform offers publishers the ability to connect real-time to every single audience member and see exactly what's being consumed where, when, and how. But also we have an intelligent brain that basically is helping optimize delivery real time. So we're a closed loop environment where publishers are continuously getting feedback from their viewers on what they're watching, and it's going through our control platform that's actually also helping the publisher implement decisions. What bit rates are optimal? How to maximize the experience real time, because the variability that hits consumption on the internet has to be managed, and it can't be managed manually. So for example, I used the Oscars and HBO's problems on the workflow There's also the middle section, which I'll call the delivery networks, whether you call it CDN or operator networks. And then there's the last mile, or even all the way to my machine or my wireless network in my house. Those are 3 layers of complexity that have to be managed, and you don't know where the problem sits. I could have a workflow problem, I could have a CDN congestion problem, or I could have a last mile outage. What we get is we have a real-time collection of the entire audience, and it's not a sample, it's actually the entire audience. And what we're seeing by, today we do over 4 billion streams. And what we do is we collect data from all of those viewers, and we're seeing exactly where the problem sits, real time. So we know if there's an origin problem, we know if there's a CDN congestion problem, or we know if there's a last mile problem. All 3 of those require completely different actions. And by the way, when I go to watch something online, you don't have time to try and figure out what I'm doing manually and then go into your workflow or call your CDN or call your last mile operator to fix the problem. I see buffering real time and I leave. So the decision capabilities and the optimization capabilities of publishers can't be delayed. You have to know, is it my origin, is it a CDN problem, or is it a last mile? And then you have to immediately act. That's what Conviva does. It's a complete closed loop. We're collecting information from every viewer, we're isolating exactly where the problem is, and then we're making real-time decisions on how to remedy that problem. We're a SaaS model. So because of the fact that, when you talk about the decision capabilities that we're making on 4 billion streams, it's not something where we sell an appliance to a customer or a license to a customer, because our value is we are seeing and making decisions on a global audience. So for example, when we work with HBO, we know HBO wants the highest quality experience. We also work with ESPN, 2 completely different types of publishers going after 2 completely different audience segments. But they have one thing in common, and that is they need to have the highest possible quality experience. So as a SaaS model, we see 4 billion streams, and we're able to optimize globally for both publishers. So the best model to reflect on how we can deliver that value is a SaaS model, because we manage the central brain, we manage the ability for that data to come into a single point and make decisions across all customers. So whether you bring 1,000 streams a month to Conviva, you're going to be getting an optimization capability based on 4 billion streams. So you don't have to re-experience all the problems that another publisher may have had. We're able to attack a common problem, which is literally just the ability to deliver content to viewers in the highest possible quality experience.